Today's webinar, and we're going to discuss the role of visual modeling in Centaur applications. And our guest speaker today is Josh Feingold, the Chief Technology Officer at Occam Systems. In his work at Occam Systems, Josh focuses on the nuanced balance between human and machine interfaces through model-based sourcing. So, Josh, can you tell us more about Occam Systems and the problems you solve for your customers?
Yeah, absolutely. Thanks, Janet. So, yeah, Jen said, I'm Josh Feingold. I'm the CTO at Occam Systems. Let me start sharing my screen. I've got just a couple of slides to kind of orient people on what's happening here. So, let's see, where are we? Here we go. All right, cool. Um, so Occam Systems is a relatively young startup company. We've been around for about a year and a half. And we really focus on uh, kind of resilient supply chains and manufacturing. But we sort of have an interesting approach to it, which is that fundamentally we have this problem that supply chains are complicated. Um, you need to produce things like, you know, now our specialty right now is fine chemicals. Um, and so we might want to say like, hey, I need to make, uh, 100,000 doses of albuterol. And I think that in the last couple of years, we've all experienced that, it's relatively easy for the US supply of pretty important drugs to just sort of like disappear. Um, and so what we want to do is enable the ability to deliver solutions in that space that benefits both the people who need it as well as the manufacturers by really lowering the barrier to delivering a solution. And so our suppliers are basically the folks who make those chemicals. Um, and sorry, the consumers are folks like the FDA, and also just kind of like organizations like Procter and Gamble that might need to procure fine chemicals for their products. Um, and then we have suppliers who are folks like Patheon and Pfizer that actually manufacture chemicals. And right now, the difficulty is that if you need to go procure a new chemical, that basically involves picking up the phone and calling around to dozens of people, or just calling the people that you already know and kind of hoping that they're going to give you a good deal, and hoping that you're communicating that correctly, and all of these different um, things that just kind of aren't very efficient. So what we are delivering is something like a rideshare app for a supply chain, right? So just very, very high level. Um, in this case, the riders have a need, which is that I'm at point A, I have this many people with me, I need this kind of car, I need to get to point B. And so they need to provide transportation solutions that are going to, get the people where they need to go and that they're going to pay the drivers enough that they want to keep driving. And so it's really the same idea. But obviously, getting in a car and riding somewhere is much, much simpler than producing a fine chemical. And so, how do you kind of cross that boundary? Um, and so, this is where the idea of model-based sourcing comes in, which means that you have to have some medium that allows for people to interact with an automated, essentially artificial intelligence system uh, that allows them to input their knowledge in ways that are familiar to them. Oftentimes, it's going to be things like Excel sheets, um, and feeds out knowledge to them. But you have to kind of reach in between those points some very detailed, expressive, precise representations of the data, so that you can actually figure out mathematically, like, how do we solve this problem? Um, and so really that's what we do, is that, on the supplier side, um, they need to know, well, what equipment do they need? How long are they going to need it for? What are the actual requirements? And on the buyer side, they want to just tell us, like, yeah, I need 1,000 kilograms of albuterol, or whatever they want. So how do you actually do something like that? Um, and at the supplier side, right, like, from the buyer side, they're just going to give us a chemical name, and they're going to give us the amount they want. And then on the buyer side, they just want to know, well, what equipment do we need, and how long is it going to take, and what are the requirements? And so that's what you really end up with, is that, you say, well, what did I ask for? I asked for, um, a production target on this sample chemical of 1,000 kilograms. These are the specifications that got pulled out when I did that, and just very simple things, just a couple of attributes, a couple of knobs to turn, that anyone who's on this buyer side is going to be able to do. And then on the supplier side, we say, hey, here are your solutions, right? And this is anonymized data, but this is actually real data. So, CMO8 in our system, hey, if you want to deliver this, here are 5 distinct solutions that use different combinations of your equipment in different roles that are part of these processes. And here are the characteristics of this. This is our estimate for how much power it's going to consume. This is how many hours it's going to take to complete. This is your overall operational cost, right? So these are all of the kinds of things. And on either end, it's very, very important to simplify that down. Um, but in the middle, it kind of gets a little bit more subtle and complicated. So I think that's a good overview. So our customers kind of actually live in all 3 of those spaces, right? So we've got a small number of pilots with these big chemical buyers. We actually have a few dozen chemical suppliers who have signed up to tell us, hey, what's your inventory? Because we think we can generate business for them. And then we actually have folks who are in the middle, and they say, well, we're not really a supplier or a buyer necessarily, but this way that you're representing this intermediate data is really interesting to us because it has applications in our space. So I think that's it.
Oh, okay. Thank you, Josh, very much. This is very helpful to know more about what Occam is doing for your customers. And friendly note here to our attendees that we have some background noise, so if you can please mute, we'd appreciate that. Thank you. Josh, what are Centaur applications and how do they fit into what Occam does?
Yeah, yeah. So kind of, I talked about, I guess we can bring this slide back up one more time. I talked about this kind of green box over here, right, where we've got really simple information over here, and we want really simple information over there. But how do you actually fit that together? And Centaur applications, and I think this term comes from chess. I don't actually know exactly where its origin is, but basically it means that you combine a human and a computer interacting synergistically to have more capability than you could get out of either one alone. And so if you think about the way that you use your computer day in and day out, you can kind of say, like, okay, well, when I, log in and watch a movie on my favorite streaming service, that's just for me. I'm not doing anything for my computer there. And on the other end of the spectrum, you have things like, if you write computer programs like I do, you are putting in text, and that text has to follow very specific rules. And if you deviate even slightly from those rules, the text will not help you. It will not do anything. You are acting as essentially a servant to the machine, so that it can do something you want it to do, but really that experience is designed to optimize the way the machine can use it, right? Like, in C and C++, you have this notion of a header file, which is this whole extra file you have to write just because that file helps the compiler do its job more easier, right? There's like all these weird hoops that you have to jump through. And so in the middle ground between those two, you can find a space where you have these things that are sometimes referred to, at least by me, as Centaur applications, where you have the human and the machine supplementing each other's capabilities and helping create a greater result than you could get. And really, one of the big benefits of this is, we've seen over the last year, especially, the rise in large language models and chatbots and things like that. And we have some very funny examples of chatbots for a car dealership that agree to sell a car for $1 or tell you to go buy a different brand of car, right? And so if you can't see inside and understand what the machine is doing, you can't interact with it in the right way. You can't give it feedback in the right way. And so a lot of what we need to do in a Centaur application is really do the impedance match between a human brain and something that a computer really knows how to interpret. And at the level that we're operating at, here, what we need are simulations. Really, we need to have a simulation of if I use the supplier's assets to address the process that's required to meet the need of the buyer, is that going to work? Right? And we don't need to do that simulation at a molecular level and all those kinds of things, but we do have to have a systems level understanding. And so what we ended up looking at was using a model-based systems engineering approach that allowed us to facilitate the kinds of interactions that we needed to have with these models to do this Centaur-centric work. And some of our customers, actually, we've got a couple dozen users at Procter and Gamble who are modeling every day, and at least certain groups at Procter and Gamble are not using these, right, the supplier and the need end of it. They're actually just using it for building out these models, because they find that it's worth it just for the models themselves. So that's kind of the third category of user is the people who live in the middle and really are these centaurs.
Oh, okay, thank you. How does Occam use visualization and other techniques to help make a subject like this accessible to humans, computers, and centaurs?
Yeah. So that is kind of the crux of the question, right? So I think probably the best way to illustrate this is just to start building something that we're going to build sort of a toy model, but it's going to represent some of the ideas that are really kind of the first experiences that people will have, as somebody who knows a lot about a subject matter, but has never worked with this tool before, maybe doesn't know anything about systems engineering or model-based systems engineering. And they're just coming into here, and oftentimes, we or one of the more senior users will just sit down and they'll just kind of whiteboard out some ideas. So this is, and as we do this, we will illustrate some of the different things that we did to facilitate being both expressive, which is very necessary for the human to get the information they need in, as well as precise, which is very important for the machine. So we have this idea of an archetype, and an archetype is just a kind of information. You can think of it as being like a data structure if you're a computer science kind of person, but it's really just like a type of thing, right? So like a dog, a cat, an animal, right? In this case, we're just going to have things, right? And for the purpose of our example, we're going to have things, and we're going to say that about things like, okay, so things always have a mass, and we're going to say that this is a mass colon mass. And what that means is that, like, I'm calling this property of things mass, and it refers to this kind of property that we already know about, which is a mass, right? And it aligns with what you think a mass is. And we're going to do the same thing here, and we're going to say, okay, so here we have a field. This one's going to be the volume, right? And up here, I typed colon mass because I knew, as an experienced user, that this was one of the choices that I could pick. But I can equally well go down here into my archetype and go, well, do I have something called volume? Oh, I do. So I started typing, and it just gave me all these lists of volumes that I might be looking for. It turns out I'm looking for this one, right? So that's great, right? So now we're talking to this expert, and he says, okay, we've got things, they've got masses and volumes. Everything that I'm about to talk about has masses and volumes. So let's just start there. Okay, great. So now, in addition to things, we've got widgets, right? And I want to make a bunch of widgets, uh, and I also want to make, but like, so I've got a system, right? And it makes a bunch of widgets, and you make those out of gadgets and gadgets, right? So that's great, right? So we're gonna have gadgets, right? Um, and a gadget is, it's kind of like a thing, right? It's definitely a thing, um, but it's also got a collar, right? And so now I want to express this idea that a gadget is it's a thing. So we're just going to take this line up here and we're going to say, yeah, this gadget provides a thing, right? It inherits the ideas that thing inherits. And so, or that thing has. And so now we're going to click on gadgets and we're going to say like, oh, well, now there's a problem. Things have mass and volume, but gadgets don't. So over here, we've got this little bug that comes up, and if I hover my mouse over on it, it's going to tell me that this is an invalid provider, right? So let me just double click on it and be like, okay, I can fix that for you. Now your gadgets work, right? Now they make a lot of sense. So if I've done something that the machine is going to complain about, the machine is going to tell me, hey, I have a complaint. And if it can fix it for me, it just will, right? And then likewise, I can come over here and I can say, I got gadgets and I got gadgets, right? And my gadgets are like they're like my gadgets, except that instead of a color, right, they have a scent, right? Um, and gadgets or sorry, gadgets are also things. So if I come up here, I can say like, okay, well, in the same way that I picked a pattern for things, I can say the same thing. Well, gadgets, yeah, get gadgets are things, right? That's fine. And when I say that, it's just going to fix it for me. It's like, oh no, no, you definitely did that on purpose. Let's not even make you click the bug. We'll just resolve it right away, right? And my widgets, I know because this is what my subject matter expert tells me. They're actually like they've got all the things that gadgets have, and they have all the things that gadgets have. We're just going to type colon gadget and gadget, and there we go, right? So now that works. So now we've kind of established our little view of what's important to us. Um, and so kind of on the topic of what is it that's important about Centaur applications in this sense, um, the answer is that I got to just kind of say the things that I knew as I knew them. If I made a mistake or the machine thought that there was something inconsistent, it helped me fix it, and it just like made my life a lot easier. So now let's say that what I want to do is talk about the system that actually does this, right? So now I've got this system, and this is my widget maker, right? And I want to put this on a slide, and so I know that I want to call it a widget space maker, but I'm not allowed to like tell a computer that something has a space in the name of it because that would not be interoperable with like any other computer system in the world, right? Like names cannot have spaces unless you're doing stuff on Windows, and that's an outlier in the world of computer systems in some domains. But if I'm just showing this to a person, they don't want to see an underscore. That underscore isn't helping them. So again, just in the interest of making things the way people would want them to be, we just say, yeah, this is just don't show the underscores, right? And it's really small things like that sometimes that do make a difference in the way people perceive, the experience. So we're just going to come in, we're going to say a widget is going to take, right? This is going to be my gadget, and it's going to be a gadget. And just like before, I can just say colon gadget, right? So one of the other things, and it's going to connect up. One of the other things that's really important that we've really tried to do is make everything really consistent, right? If I want to connect these two ideas together, I just put a colon in the other idea, and everything is fine, right? Or I can do, this is going to be my gadget, right? Um, and likewise, we can just say, okay, here's my gadget, right? And oh, I drew it to the wrong one. Let's draw it to the right one. Here we go. And then we'll just go over here. And we'll just delete this guy. Done. Okay, so, and then ultimately, right, we are going to want to make our output, and that's just going to be a widget. Okay, so now if we want to come into this space and start describing what does a widget maker actually do, we might want to have a couple functions. And I'm just going to run through several ways that, and again, so that you can start expressing logic about the way gadgets and gadgets interact to make widgets inside of this widget maker. So I'm going to create a couple of functions. The first one is I know that I want to add these together, right? So I want to find a total mass. So I'm just going to type add in here, and it goes, oh, you got an add all, an add, a q add, and a q add all. Well, what are those? Well, Q means that you're dealing with quantities and units, right? And so if you use the Q version of any function, it's not going to expect numbers. It's going to expect you to like give it something with quantities and units, and it's going to deal with that complexity. It's not going to worry about it, right? So now we said, oh, this is my function. That function is Q add, right? And just like before, I want it to do the thing that Q add does. Just do colon Q add. Everything's fine, right? And we'll call this one total mass, right? And down here on these archetypes, well, I know that these are all going to be masses, right? So I'm just going to go mass. Great, right? Mass, mass. Now I want to start connecting up my gadgets and gadgets to my total mass function. So if I do that, I can come in here and I can go, oh, so I need to get the mass out of this. So maybe I'll just put a function in here that says, oh, this is my mass. I just want to get the mass. So I'm just going to take my gadget, I'm going to pull its mass out. I'm going to put that mass into Q1. All right. And now it knows how to do that. It goes, oh, you want the mass? You gave me a thing with mass in it? Perfect. You can also just shortcut it and go gadget Q2. And now what we've done is we've drawn a direct binding. But if we click on that binding, you can see that it extracts the mass. And what that means is that we have this special syntax that says, yeah, like it's a mass. You know it's got to be a mass. Gadgets have mass inside of them. We don't need to actually draw this intermediate box unless you want it, right? If you want it there, we can, like, it's fine. Just, we'll solve that problem for you. You have expressed what you needed. We'll solve the rest of the problem. We've also got a couple other ways to do it. Maybe we'll do a volume here, right? So we'll call this total volume. And then instead of worrying about doing the actual extraction of mass for this one, we're just going to say like, okay, well, this one it just takes the gadget, right? Like that's fine. Okay, so now the total volume has a gadget, and we just said we want to connect this to that, but figured out like, okay, you don't want to connect it directly to the function. That's not right. You want to connect it to an input of the function, so we'll make that input. We'll do that for you, and then finally we might want to go one more step, right? And we're going to call this our this will be our let's call it gadget volume, right? And this will be our gadget volume, and we might want to come up to our gadget and say like, man, I just want to get the volume off this guy. So we'll put a subparameter on there. We'll call it a volume because we called it a volume. It knows that gadgets have a thing called a volume, It uses this volume pattern, so it just filled in that information for me. And then we just draw our line here, right? And so how do we then add these together, right? Like, what are the rules for combining a gadget with a volume, right? Well, we don't know. So maybe what we'll do instead of using a predefined function is we'll just write an equation here. And we're just going to say like, okay, so this is going to be my digit volume plus, you know, my gadget dot volume, right? And so again, this is really about expressing ideas in a way that makes it easy to just get the information that you need, right? And to express the ideas in a way that has very low friction, even if you're new to the environment, but that is sufficiently precise and sufficiently self-correcting that when we feed this thing into the machine, it's not going to create a lot of contention. So I think that's like a pretty good overview of the class of things that we really focus on in the Centaur environment is making it easy to express yourself, easy to be precise, easy to fill in gaps as you recognize them, um, and you know, hard to make mistakes, right? To the extent that you can do that, right? Obviously, you can never stop someone from making a logical mistake, but like the system is going to do its best to make your intent as precise as we can possibly make it. And you can always go back and correct it if we make a bad guess.
And this would make models a lot easier for humans and machines to collaborate on.
Yeah, that's exactly the point, right? So this is definitely a collaborative process, and because at the end of the day, you have to get to some place that's machine readable and machine useful because there are always two parts. If you're trying to sell model-based systems engineering into a new organization, right? Whether you're from the inside or from the outside, there are always two problems. One of them is it's too complicated. We're never going to be able to do that. That's not true. You can build an entire model with 9 buttons. There's 6 kinds of things that render basically as nodes and 3 kinds of things that render as edges. These are comments. These are some handy shortcuts. You don't even need any of these. You can do a whole real model with like 9 things.
Mhm.
Um, so that part is definitely not true. That model-based systems engineering has to be hard. In some cases, it is hard, but it doesn't have to be. And the other question is like, well, what's my value center? And I think that certainly in the model-based sourcing use case where we apply this in order to say, like, given a simple input and the need for a simple output, how do we put those dots together? Like that value equation is very simple. But even if you aren't doing that, you might have something, and I'm gonna, do a kind of a cooking show cutover where I've got a model, right? I built this model. It tells me certain things about chemistry. And I might want to say like, oh, well, I want to find out about my purified product reactor. So I'm just going to start typing purified. It's going to cycle this thing down for me. And then under my purified product reactor, I'm going to click over here and it's going to take me right to it in the diagram. And this is, there's a lot going on here. There's a lot going on here. I want to know because this is what's important to me to do my job today. What is it that I can do that affects the performance, the specifications, et cetera, of that purified product reactor? Oh, well, why don't I just do an impact reduction and I'm going to do an impact reduction up, and this is going to tell me, oh, this is like exactly just these functions. Just these functions. Out of all that complicated stuff, we're able to instantly answer the question, if this is what I care about, what other things do I have to care about? You can obviously answer the other question too. If this is what I care about and I want to change it, what else am I going to impact? Right? If I care about point A and point B and the interaction between point A and point B, what's that interaction look like? And then we can even go a step further and say, like, okay, well, in this case, I didn't just say these were the kinds of things. I said these were specific things. I gave them specific values. And so I want to come up to my purified product reactor and go, okay, like just run. It's a simulation, just run. Just tell me what you're going to do. And so it's going to say like, okay, I ran. I looked at my state data. It's got this allocated temperature managed reactor condenser. This is my overall goodness. This is probably just these two lines. These probably answer whatever question I'm trying to find out about. And if I want to find out exactly how did I derive that answer, you can have that, right? We give you exactly what we did during the simulation. But if you don't need it, these two things probably give you your answer. So again, this is about, how do we make it easy for people to understand what's the behavior of their system? Where are these emergent properties coming from? Why did it give me this answer on this day at this time? Right? These are very important things for business value.
Oh, I understand. I understand. Thank you. And it is interesting to see how Tom Sawyer Perspectives visualizations are used in your application and help support this as well.
Yeah, absolutely. So the auto layout capability, right? Like that is sort of if we couldn't do that, it would be astronomically difficult to approach this problem in a way that would keep users like connected to the content, right? So you can build an entire model just from text and keyboard interactions if you want to. Very rarely do people actually want to do that, right? Like the diagram really helps communicate, especially for new users, right? Especially when you're just coming up the curve. Those diagrams are critical to communicating and getting something that like just anybody can look at and see exactly what's going on.
Ah, that's wonderful. That's wonderful. I have another question for you. In model-based systems engineering and other engineering disciplines, we frequently experience things like version control, knowledge reuse, knowledge protection, and interoperability becoming their own hard problems, even beyond the scope of building models themselves. Has Occam looked at any of these corollary problems?
Yeah, yeah, absolutely. So I think that uh, I think that's exactly right. You often see that in order to do any kind of engineering, right? Certainly, as you all know, Jana, we have it in software.
Yes.
That you want to know what was this like? Do I have a? Can I get back to the past if I need to? And the answer is that we kind of designed all of these features in tandem, right? So we wanted to be extremely precise for the machine. We wanted to be extremely expressive for the user, and then we wanted to have these kind of supporting infrastructures in place that would help us get it. So if I come over here, right, in my UI, I can click this little clock icon that tells me, oh, yeah, here's all the changes you made, right? It just summarizes everything that I just did, and it just auto saved it, right? This is just running in my browser. I happen to be running the server on localhost right now in normal usage modes. It's deployed against the server. It might be integrated with a GitHub or a GitLab because this is a Git history log. We literally use Git, you know, behind the scenes, but nobody has to learn that, right? This just tells me what did I do, um, how do I access it, and because we're using Git, right, like this gives us this really nice interoperability with the places that a lot of organizations are already storing, these types of highly technical data representations. And so it makes it very easy, right? And they have a lot of nice control mechanisms that are built into them already. You can also do something like say, okay, well, here we kind of started from scratch, but maybe I don't want to start from scratch. Maybe I had a bunch of really good ideas last week and I jotted them all down in the model, and I want to reuse those ideas. And maybe they're in those chemical manufacturing equipment processes. So this is just another model that lives in my repository. I'm just going to drag this guy over here, drop him. Now I have a new library that says, oh, you're importing chemical manufacturing equipment requirements. Interesting. So now close this. I can come over here and look at my libraries. And now I have access to all these things, right? I have access to all of these functions. And maybe I want to make another one of these temperature managed reactor condenser allocation. I'm just going to drag that and drop it out here, right? Hit a layout, get it looking nice. Click the wrong button. Uh, and there we go, right? So this allows us to very easily pick up and reuse knowledge. And the way we've designed the system is that if you log into a model, you individually, as a user, or sometimes as a member of like an LDAP group or something, you get access to specific models. And if you open a model and that model depends on models that you're not entitled to see, you just won't see them. So this would come in and this would say, okay, this I know that this is called temperature managed reactor condenser allocation requirement instance. And then it would be called it, and this would be the ID of that thing because you would know, oh, it relates to this ID, but you wouldn't know what it was. We've really kind of tried to bake all of these ideas, into the foundational way that we structure the thing, so that all of these concerns that people have, um, we really do from the outset. And the other thing that we do, apart from using Git and having this very well structured dependency concept, is that we use RDF for serialization. Um, and well, RDF has its upsides and downsides. One of its major upsides is that it is a W3C standard, and you can go out on the internet and you can find dozens of packages that will let you interact with RDF in meaningful ways. And so even if you're not directly inside of this web client, you can just load the data. And a lot of the kinds of questions that you want to answer about connectivity now, like the things like execution and runtime, your RDF is going to be able to do on its own, right? But if you want to figure out, hey, what's connected to what in my ecosystem, those kinds of questions are pretty easily answered through Sparkle queries, right? And there are a lot of AI applications that connect to RDF semantic data. So we are deliberately building in a way that data is open, it's available to you. We don't lock it in some weird proprietary format, and we're just trying to solve as many problems as we possibly can, before they're encountered, because these are all problems that we're very very close to and very familiar with.
Oh, yeah, thank you. Thank you. So, what is next for you and Occam Systems?
Yeah, so right now, we like I said, we've got a couple of chemical buyers that are kind of getting in the process of starting their first few purchases through the system. We've got a few dozen suppliers that are signed on. We're looking to grow that base. We have a couple dozen users at Procter and Gamble that are using this just as kind of a modeling client and driver, and we're trying to grow that as well. So I think that we've also got a lot of kind of cool research ongoing with doing more of this model generation. Instead of doing it all visually, we would have a mixture of using AI to connect to, like, hey, this is a chemical. These are different ways that you could manufacture it. We're going to do, like, to kind of kickstart these models before the human even has to enter the loop. So that's kind of coming down the pipeline, and then just kind of growing up, growing out. So if anybody watching the, well, attending now or watching in the future on the recording, if you're interested in supplying fine chemicals, if you're interested in buying fine chemicals, if you're interested in having a really nice modeling experience that actually helps you like answer questions and add value and do it in a way that's like not horribly painful, and runs totally in your browser. You don't need to install anything on your desktop at all. Let us know. That's kind of where we're going.
Oh, that's wonderful. Very exciting. Very exciting. Is there anything else you'd like to add before I show our slide with contact information for you?
No, no, I think that's it for me.
Okay, wonderful. Thank you. Josh, we're so excited that you were able to be here today as our special guest as the webinar, and thank you to our attendees here live in the webinar and also those who will watch this recording on YouTube later. So if you'd like to have more information about what you saw here today or would like to connect, We do have the website here for Occam Systems and also an email for you to reach out.